the example 2 of your class lecture number 12, and this is a given beam and it has the point loading at A, C and E, and we are given that point B is a pin support and point D is a roller support, and also your support reaction is already given to you. So all you have to do here is to how to draw the shear force diagram and bending moment diagram for the given loading using the concepts that we have learned from the class, from the derivatives equation. And so from derivative equation, and uh, this force 4 kilonewton is pointing downward, so we are just going to do exactly the same. And remember that this line is your zero line, so which means that this is your reference line in your shear force diagram, and anything above this line will be positive and anything above below this line will be negative. So we are going to follow, because it has a downward force, so we know that it's going to be negative. And for our convenience, we are going to exactly draw the same arrow just to um, make sure that it is pointing downward. And then so from A to B, so we know that this is point A, B, C, D, E, and so it's given that from point A to B there's no load, and if there's no load, we know that the slope of your shear force is equal to the load intensity, and if there's no load intensity, that means the slope of your shear force will be zero, and that means it's going to be a straight line from A to B. And then from B to at point B, we see that there is a uh, support reaction of 6 kilonewton and it is pointing upward. So we'll just have to follow exactly the same. We're going to go here, from here to B is 4, and then we go a little bit above, that will make us 6. So please remember that this is not 6 kilonewton but 2 kilonewton, because the the distance from here to here is 6 kilonewton, and this is already minus 4 kilonewton. And then from B to C, there's no load, so we know that shear force has to be, the slope of the shear force has to be 0. And then from at C, because this is already 2 kilonewton, so at point C we need to go down by 4 kilonewton, so 2 already from top, a positive, and then we just have to go till here, which is minus 2 kilonewton. And this again, this distance has to be 4 kilonewton. Again, from C to D, we don't have any shear force, or we don't have any load intensity, so the slope has to be 0, so it must be a straight line again, and then it goes up till 4 kilonewton on top. This is 4 kilonewton and this is minus 2 kilonewton, and the distance again has to be equal to 6 kilonewton. And then from D to E is going to be a straight line, and then from E it will come exactly at the 0 line. So this is how we know that our shear force diagram is correct, because you can see it, this is 4 kilonewton, which is exactly what we get here, 4 kilonewton, and the direction of the arrow is pointing downward, and we can see that from here it pointed downward to come back to the 0 line. So that's how we know that our shear force diagram is correct. And this is negative, this is positive, this is negative, this is positive area. So that's how you draw the shear force diagram. And you see that um, at each point that we have a sudden increase in the load, or a point load, you see that the distance has to be equal to that load. And now that is how you draw the shear force diagram. And now how do we draw the bending moment diagram from this given shear force diagram? So we know that moment A is 0 and moment at E also will be 0. So the question is, what is the moment at B, what is moment at C, what is moment at D? What we have learned so far is from your derivatives is that the slope of the moment, here we have learned that the slope of your shear force is equal to your load intensity, and the slope of your moment is equal to shear force. So we see that the slope of your point, if the slope of your moment A to B, this moment is equal to this shear force, which is minus 4 kilonewton. And so we know that the slope has to be, and also it's a negative slope. So from there we can tell that it has to go in a negative slope in this direction. Okay, and this will be your slope is equal to minus 4. That's all we know from there, a derivative of your moment and shear force. So we know that the slope of your moment is equal to the shear force. So we know that the slope of your moment from A to B has to be equal to the slope, um, which is minus 4, which is equal to the shear force. So that's not a problem for us to draw from B to C, or from A to B. Now the problem is from B to C. If you look at the slope from B to C is positive slope of 2 kilonewton. Now the question is, how do we draw this slope? Because there are two options. Either it's going to be like this, option A, or it's going to be like this, option B. We won't know which option is correct until we find what is our MC value. What is this MC, or moment at C value? So that's what we're going to do first. But before we find the moment at C, we're going to find how to find moment at B. So moment at B can be found in two ways. We have option 1, which is using this y is equal to mx plus c. Because this is a straight line, so we use a straight line equation. Sorry, this is a linear line, so we can use a linear equation of equal to y equal to mx plus c. And it's starting at 0, so we know that c has to be 0, and your slope will be minus 4. So finally, we can say that your y is equal to minus 4x. So which means that moment at B is equal to x 1.5 meter is equal to minus 4 1.5, which is equal to minus 6 kilonewton meter. So that is your option number 1, using a linear equation. And then for option 2 is by using the concept that we have learned, that change in moment from A to B should be equal to your shear force diagram from A to B, and change in moment from A to B is MB minus MA. Please remember that change of your shear force diagram is equal to MB minus MA, not MA minus MB. Will have to be equal to the shear force diagram from A, or the area of your shear force diagram from A to B. And we already learned from here that MA is equal to 0, so your MA here will be equal to 0, and shear force from A to B, so we are talking about this particular area from A to B, which is a rectangle. So here you'll find that this is the area of this rectangle is minus 4 into 1.5. So minus 4, which is your height, into 1.5. So this will give you minus 6 kilonewton meter. So your MB is equal to minus 6 kilonewton meter. So this is exactly, you'll see that both of these answer are the same, because we use the same. We can either use from a linear equation, or you can use from the shear force, area of your shear force diagram. But I recommend that in structural analysis course, you'll be using the shear force diagram, because in your FE you'll be given a shear force diagram in your equation, and they'll ask you what is the moment at point C or point D. So what they expect you to do at that time is to use this concept of your um, uh, moment from point A to point B is equal to the integration of your area from A to B. So this will be your minus 6 kilonewton meter. And now the moment at C. For moment at C, you can use two ways. You can find that the change of moment from A to C, or you can choose change of moment from B to C. And you'll see that both of these should give you the same answer. Let's see from the first one, which is moment of from A to C. Okay, we are moving from left to right. You can move from right to left also, but when you but make sure that you uh, remember the order from A to C. Then it will be MC minus MA, and this will be equal to your integration from your shear force diagram from A to C. And you'll see that for your shear force diagram from A to C, it means that it also included this whole diagram. So it included this whole diagram, and we see that it has negative and also it has positive. So we have to be careful that there's a negative area and positive area. So for that, what you have to do is we also learned that this can be further divided into A to B VDX plus B to C VDX. From your calculus, you have learned that from integration of A to C is equal to integration of A to B and B to C. And the integration of A to B, we already calculated, that is minus 4 into 1.5. And B to C, for B to C, it is the height is 2 kilonewton and the distance is 1.5. Please remember that the sign, okay, your sign is 2 positive and then 1.5. So this will be equal to minus 6 plus 3 is equal to minus 3 kilonewton meter. And we already know that moment at A equal to 0. So this implies that MC must be equal to minus 3 kilonewton meter. And also now we can find what is the change of moment from B to C will be equal to MC minus MB, and this will be the integration of B to C of your shear force diagram. And we know that MB, we already calculated MB over here, and this MB will be equal to minus 6 kilonewton meter. So this implies that MC is equal to MC minus 6 kilonewton meter, and area from B to C, we'll know that it's equal to 3 kilonewton meter. So if we rearrange this, it'll be MC is equal to 6 minus 6 plus 3, which is equal to minus 3 kilonewton meter. So you'll see that both the equation should give you the same answer. So we know that here it is going to be minus 3 kilonewton meter. So now we can draw the diagram. This will be a positive slope, and then we'll see that from C to D is negative slope, so that will be your negative slope, and then after that you're going to be positive, so this will be your positive. And since this is a symmetry problem, so we know that this also has to be 6 kilonewton meter. So what you realize is this is negative, 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 which means that your beam will deflect it in a hogging manner. And so how do we draw the deflection for this beam? So it has to be, this has to go down. So remember that this point will not move at all because they are support reaction. So your deflection should pass exactly at the center of this point, which is the center of centroid of this the center in middle line of this beam for B and D. So for that, we are going to draw the the deflection as negative. So we know that this is a frozen phase or a sad phase, because negative means sad phase, and this has to be also a sad phase. And now some of you may confuse that this is 4 kilonewton is going down one. So you're going to say it will go like this, and then it'll go like this. This is incorrect. Why? Because you are introducing a sagging deflection here, and sagging deflection correspond to a positive moment, but we never see any positive moment in this from B to D. So which means that if you draw in this direction, in this condition, or in this way, you're going to get wrong deflection, because you are saying that this is your sagging manner, and we already learned that the moment is negative from B to D. So for that, we need to draw a sad another sad face. So it will be like this. So you'll see that both of these condition satisfy the hugging behavior. So this is a sad face, this also sad, this also sad face. Okay, so that means your deflection is correct. You can say that why this four, you can ask why this 4 kilonewton doesn't bring it down. It doesn't bring it down because this moment, the moment applied by this overhanging load is very high compared to the moment introducing by this 4 kilonewton. So you can see here the moment introduced by your overhanging is minus 6 kilonewton meter in both at B and D, but the moment produced by the 4 kilonewton is only minus 3. So you'll see that this overwhelm the whole structure, that it will, instead of deflecting down downward, it'll be deflecting upward, and then hence you get negate all your beam from A to B and B to C, C to D, and D to E has to be hugging because your moment is negative. So I hope that helps you to draw conceptually the shear force diagram and bending moment diagram from your shear force diagram, and you'll see that knowing the bending moment diagram, you can estimate the deflection, and also sometimes you can draw the deflection and you can estimate whether it's going to be a positive moment or negative moment. So I hope that clarifies how to draw the shear force diagram of any given load, and you can find the bending moment diagram if your shear force diagram is given to you. So that's it for the example 2. If you have any question, please let me know in email. Thank you.